Welcome back to Acids and Bases and Salts. In part 3 of this unit, we're going to be talking about the autoionization of water and calculations involving strong acids and bases. You will need a calculator with a logarithmic function, so get that out before you continue this video. Alright, autoionization of water means that water will automatically ionize on its own. So if you had, let's say, 2 water molecules in a beaker, probably many more than 2, automatically the water will turn into H3O plus and OH minus. One of the waters will donate a proton to the other, so that you'll have H3O plus and OH minus. In pure water at 25 degrees, the H3O plus and the OH minus should be equal to each other and will equal 1 times 10 to the negative 7 each. So, K, this is, notice a double arrow, which means this reaction is at equilibrium. K is an equilibrium constant that's equal to the concentration of the products divided by the concentration of the reactants, raised to the power of their coefficients. And then remember that liquids, pure liquids, do not get included in a K expression. So the waters, the reactants in this case, are ignored. So Kw, which is the equilibrium constant for water, is just this, H3O plus times OH minus. Now if both of those numbers are 1 times 10 to the negative 7, then Kw, which is a constant for water, will be equal to 1 times 10 to the negative 14, because 1 times 10 to the negative 7 squared is 1 times 10 to the negative 14. So if the concentration of OH minus in solution is found to be 1.4 times 10 to the negative 11 molar, then we're going to try to find H3O plus. Well, knowing that OH minus times H3O plus equals Kw, which equals 1 times 10 to the negative 14, you should be able to solve for the one if you've got the other. So H3O plus would be 1 times 10 to the negative 14 divided by OH minus. Divided by 1.4 times 10 to the negative 11, hopefully you get 7.14 times 10 to the negative 4. So that's how you're going to convert between H3O plus and OH minus. In all aqueous solutions, there are both things, H3O plus and OH minus. It's just that one of them will generally be in a higher concentration than another if it's an acid or if it's a base. Alright, so that math is going to kind of get cumbersome because of the very large, or I guess very small, exponents. So we have a pH scale and a pOH scale that'll just make the numbers a little bit easier to work with. So pH stands for the power of hydrogen. That is the exponent of hydrogen. Expresses the negative power of 10 for the concentration of H plus and H3O plus. For example, a solution that has an H3O plus of 1 times 10 to the negative 4 has a pH of 4. We're taking the power, or the exponent, of the H3O plus and just calling that our pH. As the H plus or H3O plus goes up, the pH will drop because, let's say, 1 times 10 to the negative 3 is larger than 1 times 10 to the negative 4, so the pH, 3, would be smaller than 4. So as the exponent gets bigger, the pH will get smaller. pOH is the exact same thing. It's the power of hydroxide, except that it's in regards to the concentration of OH minus instead of H3O plus. So if OH minus was 1 times 10 to the negative 4, pOH would be 4. So here's a couple of formulas that will help you get back and forth between them. pH is equal to the negative log of H3O plus, and pOH is the negative log of OH minus. You can actually type that in your calculator, the negative log of this number, and you should be getting 4, or the negative log of 1 times 10 to the negative 3, you should be getting 3. And then since the exponents in H3O plus and OH minus multiply to give you 14, that's why pH and pOH add up to give you 14. Let's try a couple of math problems in regards to this. So find the pH and the pOH of the following strong acids and strong base solutions. So you have 0.005 molar NaOH. Now in our last video we practiced writing out these reactions. So NaOH is Na plus OH minus. And it's strong, which means if this 0.005 molar NaOH completely turns into Na plus and OH minus, then the concentrations here will be 0.005 and 0.005. What's important, as far as this problem is concerned, is the OH minus concentration. And since this is a base, or since it's producing OH minus, when I take the negative log of 0.005, I will be finding the POH, not the pH. So you'll type that in your calculator, and hopefully you're going to get 2.3 for POH, because this guy is a base, or produces OH minus. So to get the pH, then you're going to take your POH and subtract it from 14, because pH and POH add up to 14, and you get 11.7. Let's look at it if it were an acid. I have HNO3, and you can put HNO3 with water, or you can just dissociate it the same way you dissociated the base, H plus NO3 minus. Or you could have done HNO3 plus water makes H3O plus NO3 minus. H plus and H3O plus are interchangeable. They're both the hydrogen ion or hydronium ion. You can use either one to mean the same thing. So if HNO3 is 4.5 times 10 to the negative 4, then H plus is also 4.5 times 10 to the negative 4, and NO3 minus is 4.5 times 10 to the negative 4. The important part of this in this problem is the H plus. So if I take the negative log of 4.5 times 10 to the negative 4, that's going to be my pH, because this is an acid, because that's my H plus concentration. And so typing that in your calculator, you hopefully get 3.35, which is my pH. To get POH, that'll be 14 minus 3.35 is equal to 10.65. Now, one quick note before we move on, just to check the reasonableness of your answer. When you're taking the negative log of some number, like say something times 10 to the negative 4, if this number in front is not 1, then this first number in front will be 1 less than the exponent. So times 10 to the negative 4 will give you a 3 point something for pH. This guy over here was times 10 to the negative 3, and it gave you a 2 point something for POH. If your number in front is 1, then your exponent is your answer. So 1 times 10 to the negative 11 would be 11, or 1 times 10 to the negative 2 would be 2. If it's 2 times 10 to the negative 2, then it would be 1 point something. That's just to kind of give you an idea about reasonableness when you're actually working out these problems. All right, so here you are on your own. Find the pH of these 3 different types of solutions. Pause the video now, type them in your calculator, and return again when you've got your answers. All right, pH is equal to the negative log of H3O plus. So the negative log of 1.4 times 10 to the negative 3. Since it's negative 3, that'll be 2 point something. My calculator says 2.85. Notice that this is OH minus for the next problem. So when I take the negative log of 8 times 10 to the negative 11, that's going to be POH, because this is OH minus, and then 10.1, because the exponent is 11, so it's 10 point something. pH is 14 minus 10.1, which is equal to 3.9. Okay, and for the last problem, we have POH is 3.2, so pH and POH add to 14. So 14 minus 3.2 is 10.8. Let's look at a couple of more. We're going to calculate the OH minus, the POH, and the pH for the following solutions. So we've got 0.1 molar HCl. What you need to know about HCl is that it is a strong acid and will completely dissociate into H plus and Cl minus. So if HCl is 0.1, H plus is 0.1, and Cl minus is 0.1. And also H plus and H3O plus are interchangeable. So if I have H plus and I need to find OH minus, that's 1 times 10 to the negative 14 divided by 0.1, which is 1 times 10 to the negative 13. And then for POH, since this is OH, it'll be the negative log of 1 times 10 to the negative 13, which is 13. And then for pH, you have two choices. You could say the negative log of 0.1, because that's your H+. Or you could say 14 minus 13, because that's total minus POH. Either way, your answer is 1 for pH. Let me make that 13 look prettier. And then let's move on to the next problem. Now I have BaOH2. It is really handy if you can write out the reaction. It helps to see what's going on. You should always be writing out a reaction for every single problem that you do. So if BaOH2 is 0.004, then Ba plus 2 is 0.004, and OH minus is 0.008, because there are two OH minuses for every Ba plus 2 or for every BaOH2. Since there's two OH minuses, that number doubles. But then that is your answer for OH minus, 0.008. So if you want to find POH, that's the negative log of 0.008. 8 times 10 to the negative 3 is 2.1. And for pH, probably the easiest thing to do is 14 minus 2.1. And 14 minus 2.1 is 11.9. Alternately, 1 times 10 to the negative 14 divided by 0.008 will give you H3O plus, and then you can take the negative log of that to get your pH. And either way, you should get 11.9. Okay, let's say this time you have pH or POH and you're trying to find concentration. And so I have a couple formulas, but first I want to think about it. Let's say you had a concentration. H3O plus is 1 times 10 to the negative 13. Then we had previously decided that pH was equal to 13, because pH is just the power or the exponent that the hydrogen or hydronium ion is raised to. So how would you go back if you started with the 13 and you were trying to get to the H3O plus? Well, that means we have to make the 13 the power, and really the negative power. So H3O plus is 10 to the negative pH. H3O plus, for my little example that I just did up there, would be 10 to the negative 13. And 10 to the negative 13 is the same as 1 times 10 to the negative 13. So what you're going to do is take 10 to the power of negative pH for H3O plus, and 10 to the power of negative POH for OH minus. So this will be the inverse log or the second log button in your calculator, usually a 10x button in your calculator, raised to the power of the pH or the POH. Let's try a couple examples of this. So first we're given pH is 3.2 and it's asking for H3O plus. So H3O plus is 10 to the power of negative 3.2, which you have to do in your calculator. You can't really do in your head. So 10 to the power of negative 3.2 is 6.3 times 10 to the negative 4. And then for OH minus, hold on, let me make that 4 prettier. And then for OH minus, you could say 10 to the power of negative 10.8, because 14 minus 3.2 is 10.8. And you get 1.6 times 10 to the negative 11. So if the POH is 8.0, then OH minus is 10 to the negative 8.0, which is 1 times 10 to the negative 8. pH is then going to be 6, so H3O plus is 10 to the negative 6, which is 1 times 10 to the negative 6. And then for our last one, again, we're given POH, so POH is 10 to the negative 5.6, which is 2.5 times 10 to the negative 6. And then for H3O plus, I want to show you two ways to get there. One is what we've been doing, 10 to the negative 8.4. And the other is going back to that very first equation, 1 times 10 to the negative 14 divided by OH minus will give you H3O plus. 4 times 10 to the negative 9 is the exact same answer as you would get if you did 10 to the negative 8.4. Okay, so those are your basic pH and POH calculations. I hope you got something out of this and that you join us next time for weak acids and bases. See you then.